I just wanted to give a quick little tutorial on how to use the drawing features in Cengage to do these Lewis structures. So this is looking for this interesting compound. Selenium is underneath sulfur and oxygen, so that's 6 valence electrons plus 14 for 2 bromines plus another 6 for oxygen. So that would be a total of 26 valence electrons to play with, which it has agreed with. And now I want to go ahead and draw this Lewis dot structure. So what I see as the issue right now is that right now what I have on the screen is a carbon. So if I want to change the element, like in this case, selenium is my first element, so that's the element in the center of my structure. I'm going to go ahead and click here. And I get a set of common elements, but I don't see selenium on here. So I'm going to click where it has my periodic table and click on SE. Go ahead and click close. And now when I click on that C, it turns it into an SE for selenium. Now I want to add a couple of bromines, so that's one of my common ones. So when I do this, I'm going to go back to my selenium. I'm going to click on it and drag out. You see that adds 1 bromine. I need 2 bromines. And then my last thing is I need an O, so I'm going to go to my drop-down box, change that to an O. I'm going to hover my mouse over the selenium, click, and drag. So I have currently used 6 of my 26 electrons. So I need to add some lone pairs to the outside atoms. So where I get my lone pairs is I go over here to this drop-down that has the plus. When I click on that, you can see here I have my lone pairs. So I'm going to click on that. Okay, so to complete the octet on bromine, I'm going to need 3 lone pairs. So I'll click on the bromine. 1, 2, 3. That completes the octet on that bromine. So now I have 26. I have now used up these, and so I'm going to go here and I'm going to go click, click, click. That's another 6 electrons. So I had 26. I used 6 to make the bonds. I've used 6 around each of the 2 bromines. So I have 8 electrons left. So now I can go ahead and complete my octet around oxygen. 1, 2, 3. Okay. Now everything has a complete octet except for my selenium, which I'm going to go ahead and finish up. And then I'm going to count and make sure that I have enough electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That's 26 electrons that goes with my 26 electrons. Everything has a complete octet. So I'm going to go ahead and hit submit. And there we go. I have a correct Lewis dot structure. So, and then I have my directions or my explanation down here to do that. If I didn't get it right, obviously I could go ahead and look at those steps. So to go ahead and do this, remember up here in this drop-down box, so here in my drop-down box, I can change my atom. This one is looking for POOH3, so I would have a P in the center. Then I would change that to have some oxygens. So I would have 1 oxygen, I would have another one, another one, another one. Then I'm going to make these H's. I'm going to have OH, OH, OH. Then I can start adding in my lone pairs where I need to have lone pairs. Notice the directions here. I do not want to have any ion charges or formal charges. If my species contains oxygen, I don't want to have double bonds unless they're needed for the center atom to obey the octet rule. So make sure you're watching out for those kinds of things. But change my atoms from this drop-down menu, get my lone pairs from this drop-down menu. If I want to change something to a double bond, you can see here I have a double bond. So I could, for example, if I want to change this to a double bond, see how when I hover over it with my mouse, it highlights those two. I can make that a double bond. If I want to make it back to a single bond, I just click back here on single bond and I click there and click it back. Or if I keep it on single bonds, you can actually see I can add, if I click, I can add a double, triple, so I can cycle through my bonds that way. So bonds here, lone pairs here, atoms here. If I need an atom that's not on this list, I can choose it from my periodic table.